Welcome to the Explainer. Today, we're diving into a brand new, absolutely mind-blowing engineering marvel in the global space race. We're talking about the kind of giant technological leaps where science fiction is literally becoming science fact right before our eyes. So, here's a question for you. How do you catch a rocket falling from space on your very first try? I mean, it sounds totally impossible, right? Like threading a needle while riding a roller coaster. But China's CASCS, that's the China Aerospace Science and Technology Corporation, actually just managed exactly this incredible feat. And let me tell you, it has the rest of the aerospace world taking notes. But to really appreciate how huge this is, we kind of have to look back at how we've been doing things up until now. Section 1. The Reusable Rocket Race, a new engineering marvel. For decades, the traditional model of spaceflight has been, well, incredibly wasteful. Historically, every single time a rocket launches, the booster, that massive bottom stage you see roaring on the launch pad, does the vast majority of the heavy lifting. It pushes the payload off the Earth, burning through millions of pounds of expertly crafted hardware, and then, well, it usually just gets ditched in the ocean, gone forever, literally every single time. It's kind of like buying a brand new airliner, flying it from New York to LA once, and then just throwing the whole plane away. That was the old model of spaceflight. Section 2. The problem with landing legs, innovation and its baggage. Okay, let's dive into this. To solve this massive, expensive waste problem, SpaceX came along and completely broke the traditional model in 2015 with the Falcon 9. Instead of ending up at the bottom of the sea as fish food, their booster was designed to actually sprout landing legs after liftoff and carefully guide itself right back down to Earth.
Now, the absolutely crucial point here is that while those landing legs completely transformed the economics of spaceflight, they came with some heavy baggage. Getting those clean, perfect touchdowns, yeah, that wasn't easy. It required a steep and honestly highly explosive learning curve. We're talking years of exploding landers and totally missed drone ships before they finally nailed the landing. Plus, those landing legs add a ton of extra weight to the vehicle. It's extra dead weight that the rocket has to haul all the way up, which actually eats into the amount of useful payload it can take to orbit.
And this brings us to China's alternative solution. CAS has unveiled this really novel hook and net system. It's a capture method designed to catch the booster midair. By snagging the rocket before it hits the ground, it completely eliminates the need for those heavy landing legs. So the booster stays light and they can maximize the payload. It's a really elegant workaround. But to really wrap your head around the sheer physical scale of this midair catch, consider this. The Long March 10B rocket stands a massive 63 meters tall. You are essentially watching a 20-story building hurtle backward toward the Earth. And it doesn't stop there. It's also 5 meters wide, and it lifts off powered by 7 roaring kerosene-fueled engines. It is an absolute behemoth of a machine. Section 3. Anatomy of a catch. Falling from the edge of space. Now, what's really interesting about this descent sequence is just how high stakes it is. About 6 minutes after takeoff, that massive booster splits away from the upper stage. It begins to freefall from the literal edge of space. As it slams back into the upper atmosphere, these small grid fins pop out. These fins are absolutely essential. They act kind of like rudders, steering this falling 63-meter skyscraper through the thickening air. Then, partway down, the engines actually reignite. This huge burst of thrust is necessary to bleed a ton of speed out of the descent so the whole thing doesn't just smash into pieces on the surface. Meanwhile, let's shift our focus back down to Earth. Out on the water, a recovery ship is waiting for it. But this isn't just a flat, floating landing pad. This ship houses a highly advanced mechanical capture rig mounted on these rapidly moving rail dollies. And to make sure the rig is exactly where it needs to be, the ship uses a super sophisticated laser tracking system. It constantly and rapidly adjusts the position of that rig to perfectly meet the falling rocket. As the rocket makes its final approach, things happen incredibly fast. 4 hooks, which are built right into the booster's body down near the base, suddenly snap open. In this super precise, extremely dramatic moment, those 4 hooks snag a set of heavy Tor steel cables on the ship's rig that are closing in to grab it. The very instant they connect, the cables stretch out. This stretching action safely absorbs all the remaining kinetic energy of that massive falling booster, bringing it to a complete suspended halt. A perfect midair catch on the very first try. Section 4. What happens next? The road to reflight. So, what's the actual goal of all this? Well, a successful catch is really only half the battle. The The true test, obviously, is whether the booster survived the whole ordeal intact enough to fly again. The real proof point, the thing that will truly bring launch costs down, is the turnaround time. And China's engineers have set a seriously aggressive target for this. They want to refly this exact same booster before the end of the year. If they can turn it around that fast, it proves the system isn't just a cool party trick, but a genuinely commercially viable solution. And I think this brilliantly illustrates the massive leap in global space engineering we are witnessing right now. To quote Dr. Ben Miles on this achievement, nailing this on the first try is, quote, potentially letting China skip the bloopers and go straight to the highlight reel. They basically bypassed all those years of crashing and exploding that characterized the earlier days of reusable rocket development, hugely accelerating their position in the modern space race. So I want to leave you with this question to think about. With rocket catching becoming a reality today, what impossible spaceflight feat will we conquer next? I mean, the boundaries of engineering are moving faster than ever before. Thank you so much for joining me for this explainer. Keep your eyes on the skies, stay curious, and I'll see you next time.